Okay, so this is problem number 3, a steel plate. So we have your steel plate in here bounded by points A, B, C, D, E, and F. So this is acted by two couples as shown. So we have the 40 Newton couple and we have the 24 Newton couple. Now, the edge of the plate AB makes an angle of alpha with the horizontal. Okay, so your AB is parallel to FE. Determine the value of alpha if the resultant of the two couples is 10 Newton meter counterclockwise. Hence, the moment, okay, the resultant of the couple is equal to 10 Newton meter. So that is counterclockwise. Now, so first, let us try to determine the perpendicular distance between the 24 Newton force. So this is the line of action of the 24 Newton force and the other is that 1 FE. So if you try to get the perpendicular distance between the 24 Newton force, so this is now the perpendicular distance, and let us try to consider that one as D. So this is now 90 degrees. So if you have alpha in there, this one is also equal to alpha. Now, let us try to isolate this triangle in here. If you try to isolate the triangle, so we have this is now your point A, this is your point F. So this one in here is now your alpha, and this is the distance D between the 24 Newton force. And this distance in here is equal to 800 millimeter. So this one is 90 degrees. So if you're going to get cosine of alpha, this is equal to the adjacent side D all over the hypotenuse, which is equal to 800 millimeter. Hence, the perpendicular distance between the 24 Newton force is now equal to 800 cosine of alpha. Let us try to get now moment. This is the moment of the couple, and let's try to get now the moment about point F. So let's try to get now the moment about point F, considering counterclockwise moment to be positive. And this is therefore equal to, so this point, so this 40 has no moment about point F. So we have 40 counterclockwise, that is 40, the moment arm is 600 millimeter, or that is equal to 0.6 meter. And then we now have your 24 on edge FE has no moment about point F because it passes through your moment center. So the 24 in the edge AB of the plate will have a clockwise moment. So we have minus 24, multiply this one by the perpendicular distance from the moment center to the line of action of this force, and that is equal to D. So this one is now equal to 40 0.6 minus 24. Then we have 800 cosine of alpha. And the moment and the couple is a counterclockwise couple, so we have positive, and that is 10 Newton meter. So it is 10 Newton meter. So it's Newton, that is meter, this Newton, and that one is 0.8. Okay, so or this is equal to 0.8 cosine of alpha. And this is therefore equal to 10 is now equal to 24 minus 24 by 0.8 is 19.2. 19.2 cosine of alpha. So we have 19.2 cosine of alpha is equal to 24 minus 10, or 19.2 cosine of alpha is equal to 14. So we now have your cosine of alpha is equal to 14 all over 19.2. Hence, the value of your alpha is now equal to the arc cosine of 14 over 19.2. Hence, your alpha is equal to 43.18 degrees. Next problem is problem number 4. So, two parallel forces, F1 and F2. They are of opposite sense. Now, so your F1 in here is equal to 125I plus, we have 200J plus 250K. So this is in newtons. And the F2 in here is equal to, in the opposite sense, so we have negative 125I minus 200J minus 250K, also in newtons. So you try to take note in here now that their magnitudes are equal, but in the opposite direction. Hence, F1 and F2 has the same magnitude, opposite in direction, and parallel in action. Therefore, this is a couple. At points A and B. So they act at points A and B of a body as shown in the figure. Determine the moment of the couple and the perpendicular distance between the two forces. So first, let us try to get the coordinates of points A and B. So we have now the coordinates of points. So we have your point A. So the coordinates of point A, so this is the x-axis, the y-axis, and the z-axis. So your A in here, x is 100 mm. So we have 100 mm. And then your y in here is equal to, so your y is equal to 70 mm. So this is supposed to be your parallel to the y-axis. And that is your 70 mm. So y is 70 mm. And your z is 150 mm. And for point B, your x is minus 100, so it is back of the origin. So we have negative 100, and then your y, your y is still positive 100, there's 1, and your z is positive 90. So it's equal to positive 90. So let us try to introduce a position vector from point B to point A. So this is now the position vector that we are now going to introduce. So this is from point B to point A. And that is now your RBA. So at this point, we did introduce a position vector. And that is now your RBA. That is from position vector RBA. So that is from point B to A. So we did introduce now. So let us try to determine now the components of the distance BA. So we have your x. We now have your y. And we now have your z component. So your position vector is directed from point B to point A. So this is therefore equal to, so this is equal to B minus A minus B. So that is from point B to A. A is now your head, so A minus B. So your A in here is 100 minus and minus 100. So that is equal to 200 mm. So we have 70 minus 100, or that is equal to negative 30. And next is 150 minus 90, or that one is equal to 60. So the position vector, ay na, adamit man dito yan. Okay, so the position vector RBA is now equal to xi. So we have 200i minus 30j plus 60k. Let's try to determine now the moment. Okay, the moment produced by the couple by F1 and F2. So the moment is now equal to, the position vector RBA cross F sub, let's try to cross F sub 1. So your moment is therefore equal to, so we have your RBA, that is 200 minus 30, and then we have 60. Your F1, the x component of F1 is 125. The y component is 200, and the z component is 250. That is your I. We now have your J, and that is now your K. So, or this is just same as, okay, so we have 200 mm is 0.2 meters. And then we have 125. So we have negative 0.03 meter. And this one is 200. And that is 0.06 meter. And that one is 250. So I, J, and K. So let's try to reduce this one. So the moment produced by F1 and F2 is now equal to, so we have your I, and then this is minus 0.03, and that one is 200. And then we have 0.06, and we have 250 plus your J. So your J is 0.06, and that is 250. And then we have 0.2, this one, that is 0.2 and 125. Plus K. So we have plus K in there. So this is 0.2, and then we have 125 minus 0.3, and this is now 200. So let us try to evaluate this one in here. Let's try to evaluate now your moment. So this is positive. So 0.03 by 250. This is equal to, so we have minus 7.5. And 0.06 by 200, so negative. So that is positive. So we have negative 12. And this is now I. We have plus 0.06 by 125. This is equal to 7.5 minus 0.2 by 250, which is equal to 50. And this is now your J. Plus 0.2 by 200, that is equal to 40. Minus, so negative 0.03. So this is negative 0.03. The negative 0.03 by 125 is negative 3.75. Okay, so your moment is now equal to minus 19.5 I, and then we have minus 42.5 J, minus and minus is plus 43.75 K. So that is therefore the moment produced. So let us try to determine now the perpendicular distance between F1 and F2 from M is equal to F, multiply this one by D. So let us try to get now the magnitude of m. So the magnitude of m is now equal to the square root of 19.5 square plus 42.5 square plus 43.75 square. And this is therefore equal to 64036. 64.036. So this is 64.036. That is Newton meter. So this one in here is Newton meter because we use 0.2, 0.03, and 0.06 meter. Now, the magnitude of F1. So we have now the magnitude of F1 is now equal to the square root of Fx squared 125 squared plus Fy squared 200 squared plus Fz squared 250 squared. This is equal to 343. This 343.693 Newton. 693 Newton meter. So from this equation, your M is 64.036. So that is Newton meter. It's now equal to F1 343.693. That is in Newton. That is a force. So that is in Newton. Multiply this one by D. Hence, the value of D is now equal to 64.036 all over 343.693, or that is equal to 0.186 meter, or this is equal to 186 millimeter. Next problem. So we have 3 couples are applied to a bent bar as shown. So we have the 100-pound couple, we have the 80 couple, and we now have the 75-pound couple. Determine the magnitude of the resultant couple and the direction angles associated with the unit vector used to describe the normal to the plane of the resultant couple. Now, first, let us try to determine the moment of the system of forces Moment of the system of forces about the reference axis. Okay, so first, let us try to get moment about the x-axis. So your moment about the x-axis, considering counterclockwise is positive. So that is counterclockwise as positive. So about there's one in here. Okay, so you try to take note that the 100-pound has no moment because it will intersect the x-axis. Similarly, this 100-pound will intersect the x-axis. Now, this 80 pounds in here will intersect the x-axis. So, itong 80 na to is now going counter. So, this is going clockwise. So, that is, okay, ito yung 80. This is the x-axis. So, it goes clockwise. And therefore, we have negative 80. So, that is minus 80. This 80 in here. Minus 80. Multiply this one by the moment arm, which is equal to 3 feet. And this is therefore equal to negative 240 foot-pounds. Okay, next is the moment of the three couples about the y-axis. Still, let us try to get counterclockwise moment positive. So this is now the y-axis. So in the y-axis, this 100 pounds is along the y-axis. So it has no moment. This 100 pound in here is parallel to the y-axis. Hence, it has no moment. Now, this 80 pounds in here is again parallel to the y-axis, so it has no moment. And this 80 pounds in here again is parallel to the y-axis, and therefore it has no moment. This 75 pounds in here will intersect the y-axis, and therefore it has no moment. So it is the 75 pounds that we're going to have moment about the y-axis, and this is going clockwise, and therefore negative 75, multiply this one by the moment arm, and the moment arm in here is equal to 4, and this is equal to negative 300 foot-pounds. Next, let us try to determine now the moment of the three couples about the z-axis. Moment about the z, considering again counterclockwise moment as positive. That is about the z-axis. So we have your 100 pounds in here will intersect the y-axis. So similarly, this will now going to intersect the z. This has moment 100 is going clockwise about the y-axis. So we have negative 100, multiply this one by 8. So we have, this is now your 80. So your 80 in here will have a moment about the z-axis counterclockwise plus 80. And I'm just going to consider that this distance in here is equal to a distance A. So this is counterclockwise. Multiply this one by A. Now, this 80 in here will have moment about the z-axis. So that is clockwise. So we have negative 80. Multiply this one by A. Okay, so we have your 75. So this is going counterclockwise. It has moment. And I'm going to consider that this distance in here is B. So we have counter, so plus 75, multiply this by B. And then this one is going clockwise. The 75 is going clockwise about the z-axis. So minus 75, multiply this one by B. Therefore, this cancels out in there. So the moment about the z-axis is negative 800 foot-pounds. Now, let us try to determine now the magnitude of the couple. So the magnitude of the couple M is now equal to the square root of mx squared 240 squared plus my squared 300 squared plus mz squared 800 squared. So the magnitude of the couple moment, okay, the magnitude of the moment is now equal to 887.468, that is foot-pounds. Now, let us also going to determine now the direction angles of the resultant couple. So we now have the direction angles of the resultant couple. So that your theta x is now equal to the arc cosine of mx all over m. So that is sequal all over m, and this is sequal to the arc cosine of mx is negative 240 all over your m, 887.468. So this is therefore equal to 105.7 degrees. And your theta y is equal to the arc cosine my all over m. So that is equal to the arc cosine of negative 300 all over 887.468. So this is equal to 109.8 degrees. 109.8 degrees. And your theta z is now equal to the arc cosine. We have mz all over m. So this is equal to the arc cosine of negative 800 all over 887.468. So your theta z is therefore equal to 154.3 degrees. Next problem, and this is now problem number 6. If P is equal to 20 Newton, so your P in here is equal to 20 Newton. Your P is equal to 20 Newton. Replace the three couples with a single equivalent couple, specifying its magnitude and the direction of the axis. Have your direction angles. So first, let us try to. Now, so if you try to take a look in here now, that the 18 kilonewton is parallel to the z-axis. This is the x-axis, this is the y-axis, and this is the z-axis. So they're parallel to the z-axis. And your P is parallel to the y-axis. So your 34 kilonewton, 34 Newton force, let us try to express the 34 Newton force the 34 Newton force, okay, say that is FED and FB. Say FED. say F, E, D in Cartesian vector form. In Cartesian vector form, your F, E, D is now equal to 34 multiply this one by a unit vector E, D. So again, your unit vector ED is now equal to a vector distance ED all over the magnitude of this vector distance. So first, let us try to determine the coordinates of points D and E. So let's try to determine now the coordinates of points D and E. Okay, so we have this one in here. Okay, so this is, I'm going to consider that is the origin of the axis. So we have, let's try to consider this triangle in here. Now, such that this is now your point O, this is your point A, this is your point B. So, this triangle in here. Now, such that your point E is somewhere else about this point. So that is now your point E. This one in here is 150 mm. This is 150 mm. So we now have, this is therefore equal to 300 mm. It's equal to 300 mm. So let's try to get this one in here, and I'm just going to consider this one as y. So this stands in there, which is equal to y. Now, using similar triangle, then we now have your OA in here is equal to 160. So this is 160 mm. So we have 160 mm is 2. So 160 mm is to 300 mm, and this is therefore equal to y. 160 is to 300, then we have y is to 150. Therefore, the value of y is now equal to 80 millimeter. So this is equal to 80 millimeter. Now, the coordinates of points. We now have the coordinates of points E. So the coordinates of point E. So it is in the x-axis. So this is your x-axis. So the coordinate of point E in the x-axis is now equal to. So that is, if you try to look at this point. So this one in here is equal to 100. So it's supposed to be up to that. So that is equal to 150 mm. So this one is equal to 150 mm. or that is equal to 0.15 meters. And the y coordinate is now equal to y, so that is now your y. So the y coordinate, that is the y-axis, that is equal to 80 mm, and therefore 0.08 meter. And we now have the z coordinate, and the z coordinate is equal to 0. We have the coordinates of points of point D. So the coordinate of point D, so this is your point D. So the x-axis, which is this one, 0. Now, the y-axis is now equal to 160 mm. This is the y-axis, or that is 0.16 meter. And the z-axis, so this is your z-axis, so this one is positive 170 mm, or that is 0.17 meters. And therefore, we now have the components of the distance ED. So the components of the distance ED, so that is D minus E. So we have your X component, we have the Y, and we now have your Z. That is D minus E. So we have 0 minus 0.15. And that is equal to negative 0.15. So the Y component is 16. That is D minus E. So we have 16 minus 0.08. And that one, 0.16 is equal to 0.08 meter. And then we have the Z component, 0.17 minus 0, and that one is 0.17. Okay, so your FED, therefore, so we now have your FED, or the your FED in Cartesian vector form is 34. Okay, first let us try to determine. Okay, so let us try to determine the your RED is now equal to the vector distance xi minus 0.15i plus 0.08j plus 0.17k. And the magnitude of this is now equal to the square root of 0.15 square plus 0.08 square plus 0.17 square. So this is therefore equal to the square root of 0.0578. 0.0578. So in Cartesian vector form, your FED is now equal to the magnitude, which is equal to 34 newtons times a unit vector ED. And the unit vector ED is now equal to the vector distance, which is equal to negative 0.15I plus 0.08J plus 0.17K all over the magnitude of this vector distance, which is equal to the square root of 0.0578. Hence, your FED is now equal to 34 by 0.15 over the square root of this one. You will going to get negative 21.213I. 34 by 0.08 over the square root of 0.0578, that is equal to 11.314J. And then 34 by 0.17 over the square root of 0.0578, that is equal to 24.042K. So we now have, let's try to determine now the components of the 34 Newton force. So your Fx is now equal to negative 21.213 newtons. Your Fy is equal to 11.314 newtons, and the component in the Z is 24.042 newtons. Now, let us try to replace now the 34 Newton force by its components. Okay, so parallel to the x-axis, I'm going to resolve the component at point D. Parallel to the x-axis is now your f of x. So this is now your fx. So that is fx. And then parallel to the y-axis, so that is vertical, and this is now your fy. This is your fy. Parallel to the z-axis is now your fz. So your Fy is equal to 11.314 newtons. So your Fx in here is equal to 21.213. So it is 21.213 newtons. And your Fz is equal to 24.042. So 24.042 newtons. Now, similarly, I will now going to resolve the component of this 34 newtons in this direction at point B. So let's try to resolve that at point B. We have, okay, so parallel to the x-axis at point B. So this is now your Fx. That is your Fx equal to 21.213. So this is now your Fy. That is your Fy parallel to the y-axis, and this is now your Fz which is parallel to the z-axis. Now, so this time, let us now ignore this 34 Newton and this 34 Newton force. We will be using now the components Fx, Fy, Fz. So this is your Fx, Fy, and Fz. Let's now determine now the components of the resultant couple. So the components of the resultant couple, we now have your mx. So it's the moment about the y, about the x-axis. Okay, counterclockwise moment, positive. So I'm going to start at this point. 18, Fx, Fy, and Fz, okay, intersect the y-axis, intersect the x-axis. And then, we now have your 20, or I'm going to start at this point. So, your F intersect the x-axis. So, at this point, we now have your Fx in here is now having a moment about the x-axis. Fx, which is equal to 20, is now, it is parallel to the x-axis, so it has no moment about the x-axis. Your Fy, which is okay, so your Fz has moment about the x-axis, so that is, so this is the x-axis, so we have a clockwise moment. Okay, so we have now a counterclockwise moment about the x-axis. Okay, so that is going. So this is the x-axis. This is now your Fz. So that is a counterclockwise. And therefore, it is positive 24.042. The moment arm is 160 mm, or that is 0.16 meters. Now, your Fy has moment about the y-axis. So, ito yung Fy, this is now your x-axis. It has moment, and that is going clockwise. So, we have minus 11.314. The moment arm is equal to 0.17 or 170 mm. That is 0.17 meters. This 18 in here intersect the x-axis. This P in here intersect the x-axis. And then, we have your P in here. So, your P is going again. So, this is the x-axis. Nandito yung P. So, that is clockwise. So, and your P is equal to 20. So, clockwise to negative, counter is positive. So, minus 20. Now, the moment arm is still equal to 170 mm, or that is 0.17. Hence, your mx is now equal to negative 1.478 Newton meter. Let's try to determine now your moment of the resultant couple about the y-axis. And this is equal to, so this is the y-axis. Okay, so let's start now with your Fy is parallel to the y-axis. It has no moment. Your Fx in here is now going clockwise about the y-axis. So that is negative 21.213. The moment arm is 170 mm. So that is 0.17. Fj in here, which is equal to 24.042, intersect the y-axis, and therefore this has no moment. So the 18 in here intersect again the y-axis. Your P is along the y-axis, hence it has no moment. Your P in here is parallel to the y-axis, hence it has no moment. Now, the 18 kilonewton, 18 newton is parallel to the y-axis, no moment. Your Fy in here is still parallel to the y-axis, so it has no moment. Your Fx in here intersect the y-axis, and therefore it has no moment. Hence, your Fj in here, we're going to have your Fj, which says your Fj in here is equal to 24. So this is the y-axis. So your Fj, this is supposed to be the direction of Fj. This is the direction of the force. That is Fj. So your Fj in here is now, so this is the direction of Fj. So your Fj is now going counterclockwise about the y-axis. So that is plus, and the value of Fj in here is equal to 24.042, and the moment arm is equal to 300 mm, or that is equal to 0.3. 300 mm, and that one is equal to 0.3. Okay, so we now have, that is about the y-axis. There's 18 in here. Okay, so it has moment. So, and that 18 in there, moment about the y-axis. So, the moment about the y-axis of this 18 kilonewton. Ito pala yung 18 kilonewton. So, that is now your Fy. So, your 18 is not along the y-axis. Rather, this 18 newton in here will now going to have a counterclockwise moment. So, this is the y-axis. Nandito yung 18. So, it has a counterclockwise moment. So, plus 18. So, this is your 18. Multiply this one by the moment arm. And the moment arm is 0.3, or that is 300 millimeter. So, your My is now equal to 9.006 Newton meter. Let's try to get now the moment of the resultant couple about the z-axis, counterclockwise moment, positive. So this is again the z-axis. So we have so let's start with this point, with this part in here. So we have 11.34. We'll have moment. So this is 11.34. We're going to have moment about the z-axis. 11.314. So this is going clockwise. So minus 11.314 is 11 about the z-axis. The moment arm in here is equal to, so about the z-axis. So this is therefore the moment arm. So this is about the z-axis. And this one is equal to 300 mm. And that one is 0.3. And then next is your, we now have your F. So we now have your Fx. So your Fx is moment about the z-axis. So it is a counterclockwise moment. So we have plus, and that one is 21.213. Multiply this one by 16. 160 mm, so that is 0.16. Fj has no moment. It is parallel to the z-axis. 18 in here is along the z-axis. Your 20 Newton P equal to 20 Newton intersect the z-axis. So we now have this one has now moment about the z-axis. So it is counterclockwise about the z-axis. So plus 20 by, okay, so this is equal to 0.3. 20 multiply this one by 0. Next is, so with this, okay, 18 in here is parallel to the z-axis. Fj in here is parallel to the z-axis. Your Fx in here intersect the z-axis. Okay, so that is 11.314. Okay, so we have 11.314.3 plus 21.213. Multiply this one by 0.16 plus we have your 20. So we now have your 20 multiply this one by 0.3. And this is therefore equal to 6 Newton meter. 6 Newton meter. So we now have the magnitude of the resultant couple is now equal to the square root. It is now equal to the square root of mx squared, 1.478 squared, plus 9.006 squared, plus 6 squared. And the magnitude of the resultant couple is 10.922. We have Newton meter. Let us try to determine now the direction angles of the resultant couple. So we now have the direction angle. Angles of the resultant couple. So your theta x is now equal to the arc cosine of mx on lower end. So we have negative 1.478. Your m in there is 10.922, or that is equal to 97.8 degrees. Your theta y is now equal to the arc cosine of my, which is 9.006 over 10.922. So that is equal to 34.5 degrees. And your theta z is now equal to the arc cosine of mz, which is 6 all over 10.922. So this is equal to 56.7 degrees.